Just before 4 p.m., students enter the classroom to find Mr. Fees dead of an apparent homicide. Everybody said they saw it coming. At 4, the temperature of the body is 80 degrees, while at 5 p.m. it was 75 degrees. It took a while for the campus police to get through the party. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? First, you're going to start off with writing down your formula because it's so easy to get lost if you just don't write your formula down. T object minus T ambient e to the negative k and little t. So this problem is split up into 3 sections, and the first one being to find the value of k, which is just another way of saying find the rate at which his body temperature decreased. So I'm just gonna lay the variables out for you guys so it'll make it easier to follow along and make it faster to solve. Okay, so big T is the temperature, and here it says that his body temperature at 5 p.m. was 75 degrees. TA, which is T ambient, is the temperature of the room, which was at 70. It was at a constant degrees of 70 Fahrenheit. Then we have TO, which is just T object. So at 4 o'clock, Mr. Fee's body was 80 degrees Fahrenheit. There's K, what we're solving for, and little t, which is time. So those from 4 to 5, it was an hour, so 1 hour. Okay, and then you can just plug your variables into the formula and then get your rate. So big T, which is 75, equals T ambient, which is 70, plus 80 degrees, which is your TO, minus TA, which is 70 again, close parentheses, E to the negative K, which is what we're solving for, times T, which is just 1. The first thing you want to do is parentheses, so bring everything down. 80 minus 70 is 10. Bring these down to then your next step, you want to divide. No, scratch that, sorry. You want to subtract the 70. Those cancel. 75 minus 70, you get 5. You bring all your other variables down. So 10e to the negative k, 1. Now you're going to divide by 10. Get your little calculator going. You get 0.5, or you can keep it in fraction form. Might be easier to keep it in fraction form, so we'll do 1/2. Equals, that cancel, e to the negative k, 1. So in order to get rid of this e, we're going to throw in a natural log, which cancels that out. So then you're left with natural log 1/2 equals negative 1 k. And all I did here was just multiply these terms together, which was the negative k and the 1, which just leaves you with negative 1k. You want to get k by itself, so you're going to divide by negative 1. And so then you're left with k equals ln divided by negative 1. So ln, you get this nasty number, and it's negative 0.6931471806, and you still have to divide by the negative 1. So when you do that, it just cancels that out, makes this positive. So your ending rate is 0.6931471.806. And that's A. Part B, which I've done over and over and over again, and I'm really tired of doing it. Determine and discuss the approximate time elapsed to the nearest tenth from time of death to time of discovery. You want to write your little formula out all over again. T ambient plus T of object minus T ambient again, E negative K to the T. You're going to use 80 degrees because that was his body temperature at 4 o'clock when those UTSA PD found him dead. Then you're going to do TA, T ambient, which was 70 degrees, plus T object. So humans, they're naturally at a 98 degree Fahrenheit body temperature. So you're going to use it to help you solve your problem. 98 minus 70 again, which is TA. E, negative K to the T. You already know what K is because we solved for it in the last problem. So now we're just solving for T. The first thing you're going to do is your parentheses. So you're going to do 98 minus 70 on your calculator because, well, you want to stay accurate. Negative K to the T. So 70, 80, alrighty. So your next step is going to be, you're going to subtract the 70 from the 80. That equals 10. That cancels, and you're going to bring your other variables down. 28e to the negative k to the t. Your next step is going to be dividing by the 28. To keep everything just a little bit more neater, when we divide the 10 by the 28, we're going to keep it in fraction form, and it gets reduced to 5 over 14 equals e to the negative k equals t. In order to cancel out this e, we're going to throw in another natural log. That cancels that out. And it leaves us with ln 5 over 14 equals negative k to the t. Now, since we already found what k was in our last problem, we're going to simply write it out. There's k. So we have ln 5 over 14 equals 0.6931471.806 to the t. And remember to bring down this negative sign. Okay. The next thing to do would be to do ln, open up parentheses, 5 divided by 14, close parentheses, and you get another nasty, disgusting number. Negative 1.029619417 equals negative 0.6931471.806 to the t. You're solving for t and you want to get the t by itself, so you're going to divide this big number by this big number. So here we go. Negative 1.06931471806 divided, that cancels that out. Write it again. 0.6931471.806. Here we go. Negative 0.6931471.806. Wham. T equals, and I'm gonna approximate this, rounding it to the nearest tenth as the instructions said, and it leaves you with 1.5. That was your time elapsed. So we know that at 4 p.m. is when the students entered the classroom and found Mr. Fees dead. So what we're going to do is we're going to subtract 1.5 from 4, and in reality it's not really 1.5. It's like if you're subtracting an hour and 30 minutes from 4. So when you do that, we find out that Mr. Fees was killed at exactly, well, we're approximating, so not exactly, 2:30 p.m. Now then, if we want to find out who killed Mr. Fees, you got to tune in to Channel 6 News later on and find out. Let's see. So that's it. Thank you for coming to class and brushing up on your Newton's law of cooling and whatnot.